Dinosaurs are some of the most famous prehistoric creatures. However, they did not evolve out of thin air. While the flying pterosaurs are their most famous relatives, there were a number of reptiles even more closely related to the dinosaurs. The clade containing the dinosaurs and these close relatives is called Dinosauromorpha. Among the most famous non-dinosaurian dinosauromorphs is Silesaurus. Silesaurus was a quadrupedal animal with long, slender legs and a gracile build. It was about 2.3 meters long, which is large by the standards of most early dinosauromorphs, though not very large by the standards of many later dinosaurs. Silesaurus belongs to the clade Silesauridae, for which it is the namesake. The Silesaurids are usually considered to be the closest relatives of the true dinosaurs. As Silesaurus is the best studied Silesaurid and known from over 20 skeletons, it is very important in understanding the early evolution and success of its more famous relations. Like all other dinosauromorphs, besides most of the dinosaurs themselves, Silesaurus lived during the Triassic period. Its fossils are found in the Drano Beds Formation in Poland, which was formed about 230 million years ago. In addition to skeletons, fossil tracks named Atropus, which were once thought to have been made by ornithischian dinosaurs, are now thought to have been left by Silesaurus. The skull of Silesaurus was narrow, though earlier reconstructions gave it a longer and less robust skull than it actually had. It had a keratinous beak at the end of its jaw that was similar to the predentary bone in ornithischian dinosaurs. Indeed, many Silesaurid fossils were once thought to have been those of early ornithischians. This is among the evidence cited by some paleontologists that Silesaurus and the rest of the Silesaurids were actually basal ornithischians, rather than merely close relations of the dinosaurs. While currently the minority position among paleontologists, it is important to remember that the early evolution of the ornithischians is in flux right now. While once thought to be an herbivore, more recent research has found that Silesaurus was actually an omnivore. Its teeth were more irregularly spaced, less numerous, and less coarse than in most dedicated herbivores. An omnivorous diet was confirmed by the study of coprolites, fossilized feces attributed to Silesaurus. These preserved the remains of arthropod skeletons, primarily beetles. As a side note, some of these are so well preserved that a new species of prehistoric beetle, Triamixa coprolithica, was named based on them. Silesaurus is thought to have preyed upon insects by scourging through leaf litter on the ground and then quickly striking, pecking in a manner very similar to modern birds. While the authors concluded that Silesaurus was likely primarily insectivorous, they still found it likely that it also consumed plants. Silesaurus's diet was between two different extremes within the other Silesaurids. Derived Silesaurids, such as Quanosaurus, were obligate herbivores, while more basal ones, such as Louisuchus, were carnivores. Unsurprisingly, Silesaurus was intermediary between those basal and derived forms and likely represents how the transition to herbivory took place. Examination of Silesaurus's bone histology has found that Silesaurus had a fast growth rate. This means that, like dinosaurs, it had a high metabolism, meaning it burned energy to produce the heat to maintain its internal body temperature. While no traces of feathers have been found on any Triassic dinosauromorph, the thermal insulation provided by feathers would have helped Silesaurus to retain this heat. Still, until fossils preserving the integument of Silesaurus or other dinosauromorphs are found, this remains speculation. Silesaurus was formerly considered a likely facultative biped, able to shift between walking on 4 legs and 2. However, a recent study found Silesaurus was a quadruped, restricted to walking on all 4s. Most other dinosauromorphs were previously considered to have been ancestrally bipedal, like the early dinosaurs. However, comparisons with other basal dinosauromorphs found their forelimbs were also much longer than previously thought, meaning they were likely quadrupedal as well. Now it seems that bipedalism instead evolved around the time of the first true dinosaurs. The same study also found Silesaurus's limbs were not like those of dinosaurs, whose femurs connected to the hip from the side. Instead, their limbs were positioned in what is called the pillar erect stance, where bone from the hips extends outwards, which the limbs attach to from below. Before this, the pillar erect stance was only known in pseudosuchians, the reptiles more closely related to crocodilians than to dinosaurs. Further examination found the other non-dinosaurian dinosauromorphs also had their limbs held in the pseudosuchian stance rather than the dinosaurian one. These findings make it less likely that Silesaurids were basal ornithischian dinosaurs, as it would have required the ornithischians to evolve both dinosaur-like hips and bipedalism independently of the theropods and sauropodomorphs. Still, this does have important implications for dinosaur evolution. It was once thought that the traits responsible for the dinosaur's success were already present in most dinosauromorphs. While this is still mostly true, with the revelation that dinosaur locomotion differed considerably from their close relatives like Silesaurus, it is apparent that the first dinosaurs were more innovative than once thought. Still, the beginnings of dinosaur bipedalism can be seen in Silesaurus. While the back legs were similar to those of other Triassic archosaurs, the forelimbs were used more for support than for propulsion. Since this was also likely true for their common ancestor, the direct ancestors of the dinosaurs only had to evolve the ability to stay supported while on two legs to achieve bipedalism. This offered the initial benefit of greater speed than walking on four legs, while also opening up new uses for their forelimbs, including manipulating food or using them as weapons. In this regard, Silesaurus has helped science to understand the success of its more long-lived relations, all while being no less remarkable itself.
Thank you for watching. Also, a thank you to Flipped StuG for narrating this video. There is a poll on the community page to provide feedback on his narration, so voting there would be appreciated. He could narrate some of the future videos, or even become the new primary narrator. Regardless, have a great day.